Hey everyone, so I just wanted to quickly go through working on the review sheet for the upcoming test. All right, so for this first one, they want to know which one is equivalent to 1 divided by the 6th root of x. So if I rewrite this, this is the equivalent to writing it as 1 over 6, 1 over x to the 1/6, which is also equal to x to the negative 1/6. Remember, when there's a negative in the exponent, that just means moving it into the denominator or flipping sides on the fraction. So we're looking to see which one of these three is equivalent to this. So 3 is definitely exactly how I wrote it. So I can get rid of choice 1 since it's not including 3. Now the thing is, I don't know if 1, 2, or both are also part of this same idea. So if I actually look at this, I can see that 1 and 2 are actually the same thing, because x to the 6th root, that's x to the 1/6, and x to the cubed root is x to the 1/3. So option 1 and option 2 are actually identical, which means those two combined will also equal 3. Because if one of them is correct, then the other one also has to be correct. But we can show why these two are equal. Remember, when you are dividing, we subtract the exponents. If you plug into your calculator, 1/6 minus 1/3 is equal to negative 1/6. So again, all three of these are the same thing. Going down to here, number 2, they give us these two equations, n equals the square root of a to the 5th and n equals a. They want to figure out what n over m is. So I just actually plug in a over a. I want to rewrite this as a exponent. So this square root means that the 5 has a divided by 2 in that exponent. I can subtract the exponents. Remember, because there's nothing here, that's assumed to be 1. So 5 over 2 minus 1. If you plug that into the calculator, this gets you a to the 3/2. From here, the 2, once again, is a root, and the 3 remains as the power on a. So choice 4 is what n over m would equal. Going down to number 3, they want to know which one represents exponential growth. Remember, when we have an expression like this, if b is greater than 1, that's growth. If b is less than 1, that's decay. So from here, I can see that 2 is definitely a decay relationship. 2 to the 9th is definitely going to be less than 1. So that one's also decay. Now, before I choose between 3 and 4, I want to note that these exponents are both negative. What that means is that if I were to rewrite these with a positive exponent, the fraction or the number in the parentheses would have to be flipped and inverted. So the 3 over 7 becomes 7/3, and the 3 becomes 1/3. From here, I can see that this number is greater than 1, and this number is less than 1. So this is my growth function. So pay attention to the exponents. Everything that we've been doing with exponential growth and decay is based off of the assumption that the exponent is positive. All right, down to 4. Remember, the way that we solve these equations is by getting common bases. So I can rewrite 9 as 3 squared. Now that the bases are the same, I can set the exponents equal to each other. I move the 2 over to the other side, and now we have a quadratic that we have to factor. So this factors into x plus 2 x minus 1. From here, I get x equals negative 2 and x equals 1. Typically, you want to just double check, but neither of these should break the equation. So my answer would be choice 3. Going down to number 5. So they want us to figure out what x and y are. So this is sort of a combination of what we just did in question 4, but also what we did in the linear equations where we had, two variables, two equations. So first, let's rewrite this like we normally do. So 8 becomes 2 cubed. Since I already had an x there, I have to multiply my new exponent of 3 with the x. So this means that y equals 3x. With the second equation, since the bases are already the same, I can actually jump straight to y equals x plus 4. Since I now have two equations where y equals, some equation with x, I can set these equal to each other. Subtract the x over. I get x equals 2. From here, I can already see that this should be my answer, but we'll just double check. If I plug in a 2 in for x, I do get y equals 6. Down to 6, finding the value for x. So again, same thing with the common bases. Here, I'm going to have to replace both the 27 and the 9. So this becomes 3 squared times 3x plus 1. And this becomes 3 cubed with an x plus 2 exponent. Again, multiply the new exponent with the old exponent. So 3x times 2 is 6x plus 2. This becomes 3x plus 6. New exponents are set equal to each other. Subtract the 3, subtract the 2, and I get 3x equals 4. Divide both sides by 3. I get x equals 4/3. All right, down here, they want to know where this graph intersects the x or y axis. So what you're going to have to do, there's a few ways to do it, but I'm just going to plug it into the graphing calculator. When you plug it into the calculator, you get your equation to look like this. Oh, oops. I was a little bit low. So it only will cross the y-axis. Now, the way you can kind of figure this out is, for the most part, any exponential function that's something like b to the x will always be above the x-axis. So it will only cross the y-axis. It won't cross the x-axis ever. If you add something to this, all that does is shift the equation up. So it will still be above the x-axis, only crossing the y. The only time you could ever get this graph to cross the x-axis is if you subtract by some number. I don't know what that number is. It really depends on your numbers, on the exponents and all that. But that's why I was saying that for the most part, you should just plug it into a calculator and see what you get. All right, down here. So they want to know which one of these graphs will look like our relationship. Again, we can graph it to see what it would look like. Most likely, our choices will be one of these two. I'm thinking it's going to be number 3, so let's just double check. 200 times 1.5. Pay attention to the negative on that exponent. And the equation looks like, just waiting for the graphing calculator to work. Yeah, all right, so it looks like it's going to be number 1. Pay attention, because if you use the graphing calculator, you might have to make sure that you go to the proper scale. Yeah, so one way that you can realize this is if you rewrite this equation so that it has a positive exponent. Remember, we're doing 1 divided by 1.5 to the positive x. This rewrites as 2/3 or 0.67. This is a decay. So we're expecting a decay relationship as we see in number 1. All right, number 9. So they want to know where this function lies within these quadrants. Remember, the quadrants are these: quadrant 1, 2, 3, and 4. It goes counterclockwise. So once again, just plug it into the calculator. Negative 1/3 x. Pay attention to the fact that the negative is on the outside of the graph. Once again, graph it so it fits. The equation or the graph should look something like this. So it looks like it's in 3 and 4. All right. So this, they want us to basically explain in words how we can figure out this as an actual number. So you could say rewrite as a cube root. So what we would do is rewrite this as cube root 3 negative 8 to the 4th. Then you find a number, raised to the 3rd. That equals negative 8. In this case, that would be negative 2. If you plug it in your calculator, you get negative 2 times negative 2 times negative 2 gets you negative 8. And then you would raise negative 2 to the 4th. And that will get you negative 2 to the 4th. Will get you positive 16. So that would be the answer. Again, they weren't asking you to answer it. They were asking you to put it in words, what you would do. So this could be done similarly. So you could say that you multiply the two exponents. You get 2/5. Turn this into a 5th root. I'm not writing everything I probably would have written, but I would normally also write turn into a 5th root with the square underneath the radical, so it should look like this. Take the square of 3. and you get the 5th root of 9. So again, what you're doing is doing it yourself, but then writing out in words what exactly you're doing. Here, they want us to graph this between -1 and 3. If we wanted to, we could make an XY chart. They want us to go from -1 all the way up to 3. So we can put these into our calculator. 2 to the -1 is going to give us 0.5. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. And this is 8. Just make sure that you put this in properly. So we'll do 1, 2, 3. And this will be -1. This has to go all the way up to 8, which is right here. So that's 8. This is 4. That's 2. All right. So my equation will look like -1 is a half, 0, 1, 1, 2, 2, 4, 3, 8, and will look like that. The question is, will the graph ever intersect the x-axis? No. One way you can say it is that 2 to the x power could never equal 0. You could try proving that. That would be a little bit tough. You could also say that that there's no way to get a negative number in for this, since no exponent, like raising a positive number to any exponent will always give a positive number. You could say that because it's just a standard exponential equation, it's always going to be above the x-axis, and the x-axis is an asymptote of it. All right, this one, they want us to graph this on the x-axis. So this one's a little bit trickier. What I'd recommend is, again, plug it into your calculator. If you didn't want to do that, you could just plug in numbers between 1 and 10. So 400 times 4 to the 5th to the 2x power minus 4. All right, so I'll have to put a little bit of numbers in between here. So let's see. So each one of these is 20. One, that's 200. That's 300. And that goes up to 400. So at 0, it goes up to 396. So that would be like right about there. At 1, which is every 2 lines, this should go down to 250. So goes down to there. Next one goes down to 160. Three goes down to 100. This goes down to 63. With this, it doesn't have to be exact. This goes down to 38, 23, 13 would be right about there. 7 would be about here. And it just starts getting closer and closer to this x-axis. And then we have to make a curve that goes through these points as best as we can. And there we go. easy enough. For this, you want us to solve this for all the values of x. So again, we do our standard where we're trying to rewrite our equations with the same base. So 3 to the 4th turns into is 81. 27 is 3 cubed. Multiply the old and new exponents. So this becomes 4x cubed plus 8x squared. 3, that becomes 15x over 3, which actually simplifies just to 5x. So this, if I move things around, so that's supposed to be negative. Pull out an x from the entire thing. Make sure that you actually divide each an x out of all of these. From here, we have to sort of factor this, so we're going to have to be a little careful. This one's actually kind of a tough factor, so we're probably going to have to pull out the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So this becomes negative 8 plus or minus square root 8 squared minus 4 times negative 5, 144. This simplifies to be negative 1 plus or minus square root 144 is 12. So this factors as 11 and negative 13. In addition to that, we have this x still here. So if we actually rewrote this factor, which I'm not going to rewrite it, we have 3 solutions, 0, 11, and negative 13. I can plug this in and I should end up getting the same thing on both sides. One thing to note, this goes back to quadratics. Whatever power that x is, whatever the highest power is, typically refers to how many solutions we should have. So because that's x cubed, that means that we have to have 3 solutions. So keep that in mind. This is the last one. So they want us to solve this equation. The nice thing is that these bases are the same, so I can immediately go to setting the exponents equal, move the 4 over, factor this. So this will become x plus 2, x plus 2, which means x equals negative 2. I can plug that in, and I should get the same thing. Now, note that one of the things I did mention was that, there's always going to be a 2 solutions for this, though you'll notice that this actually only has 1 solution. Technically, there is a second solution, but you don't need to worry about it. All right. If you have any questions, please let me know. Otherwise, good luck and have a great day and good luck on the upcoming test.